Next we are going to see parametric equation of a circle. Parametric equation of a circle with center hk and radius r are given by x is equal to h plus r cos theta and y is equal to k plus r sin theta, where theta lies between 0 to 2 pi. So we'll see the proof. Let c h comma k be the center of the circle. So this is x-axis, this is y-axis, O is the origin, this is the given circle with center c h comma k. Let p x comma y be any point on the circle. So consider the point p x comma y on the circle. Join cp. Clearly cp is nothing but the radius r of the circle, right? So draw cx dash parallel to ox and cy dash parallel to oy. We are creating two parallel axes. One is parallel to x-axis and one is parallel to y-axis, right? So this is ox dash, so that is cx dash, and this is cy dash, right? Let angle pcx dash is equal to theta, pcx dash, right? That is theta. Draw the parallel line to oy from p which meets ox dash at n and ox at m. Now we are going to draw a line parallel to oy from p. So starting point p, so we are drawing a point, it's a line parallel to oy which meets ox dash, right? That is cx dash, not ox dash, cx dash at n, right? And ox at m. Clearly pm which is equal to y, that is pm is y distance of the point p and om is the x distance of the point p, right? X distance x and y distance y, that is y and this is x. Draw a parallel line oy from c which meets ox at d. Now we are going to draw a line from c parallel to oy, right, which meets ox at d, right? Now clearly cd which is equal to, that is cd is the y coordinate of the centers, that is k, and od is the x coordinate of the center, that is h, right? This is k, this is h. Now cn, the distance cn which is equal to dm, cn and dm are equal, right? Cn and dm are equal. So dm can be written as om, the length om minus od, so x minus h, right? That is x minus h. Now pn which is equal to pn which is equal to pm minus mn, right? pm minus mn, that is pm minus mn, which is nothing but cd. cd and mn are equal, so pm minus cd, that is equal to y minus k, right? Now from the right angle triangle cpn, right? So cos theta is equal to adjacent side by hypotenuse, right? cn, that is adjacent side, and hypotenuse is cp, right? Because opposite side is opposite to the angle theta, that is pn, right? Now the cn is adjacent side and cp is hypotenuse. Cn by cp, that is equal to x minus h by r. Therefore x minus h is equal to r cos theta, therefore x is equal to h plus r cos theta, right? Now similarly, that is equation number 1. Similarly find sin theta from that, opposite side by hypotenuse, opposite side pn divided by hypotenuse cp, that is equal to y minus k by r. Therefore y minus k is equal to, just to do the cross multiplication, r sin theta, therefore y is equal to k plus r sin theta, that is equation number 2. So equation 1 and 2 represent the parametric equation of the circle. So any point on the circle can be represented by this x comma y, that is h plus r comma theta x coordinate and k plus r sin theta y coordinate. This is the parametric representation of a point on a circle, right? So the center of the circle is origin and radius r. Then the parametric equation of the circle is, so x is equal to r cos theta and y is equal to r sin theta, because h comma k equal to 0 comma 0. The point h plus r cos theta and k plus r sin theta represent a point theta on the circle with center h comma k and radius r. First problem. Obtain the parametric equation of the circle x square plus y square minus 6x plus 4y minus 12 equal to 0. Given equation of the circle is x square plus y square minus 6x plus 4y minus 12 equal to 0. That is equation number 1. From here 2g, that is coefficient of x minus 6, therefore g is equal to minus 6 by 2, that is minus 3. Then 2f coefficient of y, so that is equal to 4, f is equal to 4 by 2, 2, and c is the constant term minus 12. Center of the circle 1 is minus g minus f. We know the standard formula, which is equal to minus of minus 3 comma minus 2, that is 3 comma minus 2. And the radius of the circle 1 is, formula is root of g square plus f square minus c. Substituting the values, 3 square plus minus 2 square minus of minus 12, so you will get root 25, that is equal to 5. Therefore the required parametric equation of the circle is x is equal to h plus r cos theta, comma y is equal to k plus r sin theta. Theta lies between 0 to 2 pi. Therefore x is equal to 3 plus 5 cos theta and y is equal to minus 2 plus 5 sin theta. Right? Here h comma k 3 comma minus 2, r is nothing but 5. Next problem. Show that the locus of the point of intersection of the lines x cos alpha plus y sin alpha equal to a and x sin alpha minus y cos alpha equal to b. Alpha is the parameter. Is a circle. So we need to show that the point of intersection, locus of the point of intersection of these two lines is a circle. So given lines x cos alpha plus y sin alpha equal to a, that is equation number 1. Second line x sin alpha minus y cos alpha equal to b, that is the second line. Let p x1 y1 be any point of intersection of 1 and 2. So these two line point of intersection of 1 and 2, these two line point of intersection is nothing but p x1 comma y1. Since p x1 y1 lies on both 1 and 2, because point of intersection means it is lying on the both line, so it satisfies the line equation 1 and 2. So put x is equal to x1, y is equal to y1. So x1 cos alpha plus y1 sin alpha equal to a, and in second equation implies x1 sin alpha minus y1 cos alpha equal to b, that is 3 and 4th equation. So 3 square plus 4 square, squaring and adding, so x1 cos alpha plus y1 sin alpha the square plus x1 sin alpha minus y1 cos alpha the square equal to a square plus b square. So squaring a plus b whole square formula, first bracket. So x1 square cos square alpha plus y1 square sin square alpha plus 2 x1 y1 cos alpha sin alpha. Second bracket square, that is a minus b whole square formula. X1 square sin square alpha plus y1 square cos square alpha minus 2 x1 y1 cos alpha sin alpha, which is equal to a square plus b square. So grouping x1 square term. So x1 square into cos square alpha plus sin square alpha. Similarly y1 square term, y1 square into cos square alpha plus sin square alpha. Here plus 2 x1 y1 cos alpha sin alpha minus 2 x1 y1 cos alpha sin alpha get cancelled. So remaining, which is equal to a square plus b square. We know cos square plus sin square equal to 1. Therefore x1 square plus y1 square is equal to a square plus b square. This is nothing but the locus of the point x1 y1, that is which is in the point of intersection of these two lines. So this locus gives a circle equation, right? X locus is nothing but x square plus y square equal to a square plus b square. So x square plus y square equal to a square plus b square means that is the equation. So x1 y1 is lying on that x square plus y square equal to a square plus b square, right? Then it satisfies, right? So reversely you think, right? So x1 square plus y1 square is equal to a square plus b square. That is why x1 y1 satisfy the equation x square plus y square equal to a square plus b square. So locus of the point is nothing but x square plus y square, which is equal to a square plus b square. This is the in the form of standard circle equation which passes through the origin. We know x square plus y square is equal to r square. Instead of r square, you are having a square plus b square. That means r is nothing but the root of a square plus b square, right? So origin is 0 0 and radius is root of a square plus b square, which is a circle, right? Thanks.